Hello everyone, this is the presentation for EFHQ, Multipurpose ExtremePose-Face-HQ dataset. First, about the current state of the face dataset. The majority of samples in commonly used datasets are in the frontal view. This creates an inherent pose bias in trained models. Recent datasets that focus on extreme views only primarily target image generation, which limits their broader application. Therefore, we propose EFHQ, an extreme face dataset, complements existing datasets on multiple facial-related tasks. Training with EFHQ helps models perform well across diverse poses, significantly improving performance in multiple tasks involving extreme views, such as face generation and face reenactment. Despite significant advances in face generation and recognition models, these models still exhibit weaknesses when dealing with extreme poses due to several reasons. First, their performance degrades since most existing training datasets contain predominantly near-frontal images. Moreover, there is currently no efficient pipeline to extract extreme head poses from available video-based datasets to solve this issue. Hence, a comprehensive dataset with diverse pose is needed for better benchmarking and validation of facial generation models. However, building a pure extreme pose dataset is challenging since extreme head poses are more prone to result in wrong predictions, rendering pseudo-labels produced by pre-trained models unreliable. It is also difficult to combine new datasets with existing ones without compromising the balance and diversity of data. With these in mind, we propose EFHQ. Our data pipeline begins with extracting facial attributes from original video frames of EFHQ and CVPR. For pose information, we categorize pose estimations into different groups. We perform majority voting on all pose estimators' predictions to arrive at the final labels. When no appropriate labels are found, these cases are then manually reviewed and corrected. After review, we perform task-specific pre-processing to create datasets for each subtasks, such as face synthesis or reenactment. Due to the instability of pose estimators when predicting extreme poses, we apply 3 pose estimators: SynergyNet, DirectMHP, and in-house FacePoseNet. Therefore, if one model fails to predict the correct pose, we can rely on the predictions of the other 2, hence creating a robust and stable prediction pipeline for extreme poses. Our data processing pipeline can preserve more samples when compared to LPFF's proposed pipeline, hence proving the robustness of our EFHQ pipeline. Our proposed dataset demonstrates greater pose diversity, with increased sample counts across high-angle bins for yaw and pitch angles. Regarding face synthesis, with StyleGAN2 models trained with EFHQ perform significantly better in both metrics in cross-training/evaluation set scenario, while maintaining competitive metrics in same training/evaluation set scenario when compared to LPFF-trained models. Finally, our conditional model demonstrates substantially improved scores over multiple reference datasets. Visually, our model demonstrates clearer and more realistic generation of eyes, nose, and mouth regions. Here is more examples of face synthesis using StyleGAN2 trained with EFHQ. Similar trends apply to 3D-aware generation using EG3D. Our model trained with EFHQ achieves a similar FID while improving other metrics compared to the EFHQ baseline. Compared to the LPFF version, our model is superior when evaluated on both the EFHQ and respective training sets. Here is some visual comparison using EG3D. Our dataset also aims to improve text-to-image models in generating realistic faces in extreme poses, especially in the eye regions, which is a common issue found in stable diffusion. In the face reenactment task, both models, when trained with additional EFHQ data, achieved virtually similar performance on VoxCeleb compared to our baseline trained with only VoxCeleb. However, in our evaluation set of frontal to extreme face reenactment, our model significantly outperformed the baseline, demonstrating high quality and versatility in various reenactment scenarios. Models trained on traditional dataset fail at extreme views, while ours correctly generate the identity and motion in the output. Our EFHQ also acts as a potential benchmark for face recognition and face verification tasks. Our proposed EFHQ evaluation benchmark involves 3 pose-based scenarios: frontal-frontal, frontal-profile, and profile-profile. Results reveal that performance drops of 5 to 37% on the frontal profile and profile-profile subset compared to frontal-frontal scenario, highlighting the challenge of matching faces in different poses. Similarly, our dataset also offers open/closed set 1 and benchmarks for face identification task. Moreover, utilizing EFHQ as additional training data for face recognition improves models' performance on both pose-focused as well as traditional evaluation set. In conclusion, EFHQ addresses the critical gap in facial datasets by providing high-quality extreme pose images. Models trained on EFHQ exhibit improved generalization, robustness, and accuracy in face synthesis, reenactment, and recognition. Further research and development can leverage EFHQ to explore new applications and improve existing face-related technologies. Thank you for listening. Please scan the QR for more information on our project.